All right, I'd like to welcome all of you to the next in the series, the PTC User Expert Speaker Series. My name is Ron Watson. I'm part of the Board of Directors of PTC User. In my real job, I work for Xylem Incorporated as the Director of Engineering Systems and Processes. PTC is bringing you this webinar series for the benefit of the community. And to share knowledge. That's part of our mission. I'll talk about that in a minute. So we're here to talk about design process automation, improvement in automation. Michael Denis and Tanner Gwynn. They're both from systems engineers from Carrier UTC. This webinar is being co-sponsored by PTC User and our friends at sigmax, who are on as well. Next slide, please. All right, so most of you are aware of PTC User, so I'll just briefly go through this. You know, our mission is to support, educate, and advocate for the community of PTC customers, and that's all PTC's products. The important part about this is not about me, this is not about PTC User, this is not about PTC, this is all about you. And we need you to participate, not just attend, which is fantastic, and collaboration and questions, but be a speaker, step up, you know, share tips and tricks, participate in the future panel sessions. Those take a lot of work to prepare, but we had I think we had nearly 300 people at the last panel session we did last year. And you know, send us a short video. We're not getting a lot of traction there, but we're looking to expand that. You will see in the next few months an enormous amount of content on our YouTube channel. You don't know how much content. I had an Explorer full of content that was converted digitally. So we have a lot, literally, old videotapes. And just contact me, ronw@ptcuser.org. It gets routed to my Xylem email, and I'll be glad to discuss it. By the way, we have some future webinars lined up that you're really going to enjoy and related to what Michael's going to talk about today. So next slide, please. So what do we have going on? We have a lot going on. So we're no longer that one big conference that we used to run every summer, which was a great event. Now we have LiveWorks, but we have a lot of other events. So Vertex, near and dear to my heart, I attended the last Vertex user group meeting before PTC acquired them. We were an Vertex customer long before PTC probably even really knew about them. So it's in Ann Arbor, Michigan, which is the birthplace of Vertex, an appropriate place. It's free. If you're in the area, by all means attend. Again, if everybody can mute their phone, I'd appreciate it. Next slide. So LiveWorks 19, it's coming. We're here at PTC talking about it, and we have a lot on the agenda and more to come. Let me see if I can clear that up. Again, if anybody on the phone could mute, I'd appreciate it. I'm not seeing. I got it. All right. So thank you. So important thing is use our code. PTC User 19 is the code to use. We are told that no matter what other discount or promotions going on, that will get you the better rate of that promotion. It will discount it. So please use it. It's good for all of us because we get a piece of every register, per person who registered, just like we did when we ran the conference. So it's important for us to operate. So it's good for you. It's good for the community to do. You get a best price, and we get more investment. There's a lot of content. The exhibit hall, the Extropolis, is going to be completely redesigned around solutions. I don't want to give you any more because it's going to be really, really nice. PTC User, our 30th anniversary, we are the prominent booth as you come into the hall. So keynotes have already been announced. There's more to come. Next slide, please. The CAD PLM day, by popular demand, we added a Monday. Now, I know some of you have registered, and you've done the right thing. You've registered early. If you have, you can go back. If you have the all access pass, you can go back and you can add it. right? So you're going to get it for free up until a certain point. I think May 1st, then it's no longer free. If you signed up for a different pass and you want to add this, please let me know. We'll put you in touch. And we talked. Some of us already talked about this. You will get the rate that was back when you first registered, not the rate that's showing up today. So that we understand there was a gap there. This wasn't available this day when we first registered. So we've worked with the PTC people that manage the registration to make accommodations for all of us. But this is going to be a CAD PLM day. Great content. Plan for it. Don't miss it, and I can tell you in future years it'll even be more expanded. So we're kind of going back to our roots here. So next slide. So the technical committees, a little bit different. We're not having an open forum this summer like we did last summer because we're having the Monday CAD PLM day, but we do have the technical committee meetings on Thursday, and that'll be at the exhibit hall. I mean the event. Convention Center. However, on Friday, there'll be a read back at PTC's headquarters where I am, and so that you'll get an opportunity to have a tour as well and hear what all the working groups are reading back. So I just left a session completely dedicated to working groups. We're making big investments of time and energy and resources into improving the working group. So by all means, participate. And next slide. Big announcement. This was first done last week. Rocky Martin's presentation, Integrity Day. So those of you who are interested in integrity, a dedicated day for those. Again, some of you may not be, but this is good to know, right? That we have a dedicated day for people interested in that area. And again, this is ALM. You're right. Application Lifecycle Management is becoming, a bigger, more important part of all our companies as we move from just physical products to digital products as well. Next slide. And then the big news: our next open forum in winter 2020 is in a very warm place to be in, below the freeze line. Certainly, January next year. We're at a beautiful resort. I had the opportunity to stay at this resort with my family a couple of nights last year. We happened to be on vacation there, and we're developing great content for our 30th anniversary, especially. It's a beautiful property in just a really exciting time, because if you look at the metrics, our growth in these winter forums is going up. I mean, we started less than 200 people 3 years ago, and we're over 300, and so the growth is there. Again, an open community. It's not just technical committee people. We're expanding content. Jennifer and Sigmaxim, along with other great partners, are investing more in this. They see the value in this over the big events like in June, and it's more intimate. You get to network more, etc. So please try to attend if you can. Next slide. The portal's redesigned, and we continue to redesign it. If you go to where the webinars are, under our library, you will see, in fact, if you could flip to the next slide, please, you will see all our webinars in a nice, neat order in a tiled format. So, Michael, if you could switch to the next slide, you'll see that, and we're oh, I'm sorry, I thought I made the screenshot, but if you click there, you'll see it in nice, clean order. It's linked to our YouTube channel. The presentations are attached. We're going to be doing this more and more with all our content, make it very easy for you to access. So if you're not already a member, go to ptcuser.org. It's free to be a member. Join the almost 20,000 other people that participate in the group. Next slide. What I'd like to do is hand the baton over to my good friend Jennifer, and she's going to introduce you to Sigmaxim, our co-sponsor.
Great, thanks so much. First of all, I'd like to thank you for having this, and also for Michael and Tanner over at Carrier. This is really exciting. I just want to take just a few seconds to introduce us. We're Sigmaxim. engineering automation specialist. We've been in business since 2001, headquartered in Boston. We have global operations as well as a global client base, PTC software and service partner. I wanted to keep it brief, and I'll hand it over to Michael.
All right, this is the same slide we saw at the beginning. Myself and one of the other design automators we have here in Charlotte will be presenting a few videos that demonstrate what we've done in the year and a half, 2 years we have been using SmartAssembly. Just a little bit of background on carriers so that you know what we're talking about when we're showing you the videos that are about to ensue. I'd like to start by asking you to hold questions till the end so that we can get through all the videos. We're running a tight schedule today. And I do show my email at the end of my presentation so that if you have anything, write it down, and if you don't get a chance to ask today, you can send it to me via email. We work out of the Charlotte facility in Carrier. We primarily do large-scale chillers. You're seeing one chiller from each of our product lines on the right there. An applied chiller has a less discrete operating range, but in order to hit every different performance level in their operating envelope, you need to have a more configurable product, which means more design work. A package chiller is more modular and discrete. Big differences are that they're usually air-cooled and don't need a water-cooled condenser. And so we will be showing programs that, I'm sorry, is someone not on mute? We will be showing videos that apply to both product lines during our demonstration today. Now I'll turn it over to Tanner so that he can introduce the first of our tools.
Thanks, Mike. So in order to show some of the functionality of SmartAssembly and how it factors into our workflow, like Michael said, we decided to show a couple of videos of the programs we have developed and that we're using today. Due to certain IP issues, be a little bit careful about showing code and an abundance of dimensions. So just keep that in mind as we go through these. So as Michael said, we have two different types of product lines here. We have applied chillers as well as package chillers. Well, this picture on the bottom is a cutout of one of our package chillers, and as you can see, it has a lot of copper tubing. You can see all of this here is in copper tubing. So each one of these, we first have to make a 3D model and then make a drawing of the 3D model. So in order to cut down this design time, we thought it would be great if we can automate at least the drawing portion of it. So what this copper tube tool does is it takes a 3D model and it makes a drawing from it. And due to the large amounts of copper tubing and on all of the products across the package lines, it is massive time savings and it gets used on a weekly basis. Now, some of the challenges in automating this process were inconsistent design practices, but with the release of a standard of work, when we released the program, it actually both standardized the drawings themselves because the drawings were automated, but indirectly it standardized our 3D models because our designers wanted to be able to use this program, so they adhered to the standards that were required by this program. So I'm going to jump into our video of this program real quick. So how this program works is it looks for a spreadsheet and the working directory of Creo, and in this spreadsheet would be a list of a bunch of part numbers. And what it does is it searches for these part numbers in either the working directory, or if you're connected to a data management software, for us it's Windchill, it searches and validates in Windchill and saves to Windchill. Now, for this example, I'm not connected to our data management software, so I will have to go and make sure that my working directory is set to the right place. So it's looking for these parts in the right place. So right now I'm going to go ahead and look at my working directory, and I see that it is in fact selecting in my tube drawing folder. So I'm going to go ahead and run this program. And right off the back, it's going to start searching for these parts and validating them. As you see this top list here, it has identified these tubes and validated their proper type. The way that it validates these is it looks for pro-piping features. It has the features that says, yes, it's okay for this program to be used. And if not, see this one, 8675309 is actually not an item number. It's not a part of my working directory, so it said it cannot be retrieved. And then it could retrieve that 9999 part. However, it did not have any pro-piping features, so it's saying we cannot use it. Now, if this list was full of items that cannot be found, I might look and make sure my working directory is pointing to the right spot. But I decided to go ahead and continue because it found at least 2. So now that I continue, it brings us to one of the first great functionalities of SmartAssembly, which is this right here. This is a graphical user interface, which for the remainder of this webinar we will refer to as a GUI. Now with these, we can both represent data in the form of pictures or charts. We can also manipulate data as far as parameters go, maybe certain inputs, as well as selecting different features and edges. So as you see here, it's looking for a tube drawing name that we can change. It actually pulls this drawing name out of the model itself and populates it already. Wants a burst pressure, asked to choose a department, whether it's applied or package, and then it's also requiring a start point and an end point. So first I want to make sure that my CSIS and points are displayed. And then as you can see, the start coordinate system is already black and end point is red. That means it already searched for something labeled start, found that coordinate system, and it pre-populated it. Now I'm going to show here that you can, after the pre-population, in fact, change it. So you see there, it says start a little bit. Once I click on it, you'll be able to see that, you can see that start in the background. Now I'm going to go ahead and select my endpoint reference here. I'm going to be okay with this drawing name. Say it's an applied department, and my burst pressure is 218 psi. Now I'm going to continue on from here. And it brings me to our second GUI. Now in here it allows me to adjust any of the parameters that we chose to put in here. Again, it's pre-populating from the model. So if I wanted to change any of these materials or anything, I could. Now then we would obviously have an issue with our 3D model agreeing with our drawing, but I can adjust any of these I choose to do so, and I represent that here by adding a part name language. The rest of this is okay, and I'm going to continue. And then it makes our drawing for us. Now, next message box brings should ask if there are any end details for this tube drawing. As you can see here, there is a bell end, so I'm going to say yes, I want to make end details. So for the first end, it's unfinished. For the second end, is a bell end. All right, and now as you see down here, the whole time you can actually print things to the message window in Creo. So right now it is asking for us to select a parent view for in detail view. So I'm going to go ahead and select that view. Then it's going to ask me for a couple more dimensions. So it's asking for the bell inner diameter. I'm going to select that diameter, select a couple more dimensions, and it's going to make my detail view. All right, so it has made my detail view. As you can see down here, I got my start location, a couple different dimensions. Here it's saying see detail A. I have detail A. I'll probably move it over here for a little bit of cleanup. And I also have things like my title block down here. Populates everything for me. I have a disclaimer note that our company uses over in the left-hand corner. My bin table, as well as engineering notes. Now, in these engineering notes is actually that 218 PSI that we inputted in our first GUI. Right, so everything here is good, so I'm going to continue. Now it brings us to our next part, and again, it brings up the graphical user interface first, and pre-populates the drawing name, and if you notice, it remembers the 218 that we put in on the first one, and it keeps, in case you want to use that again, keeps the same note for applied. it found our start coordinate system, and it's just looking for an endpoint reference. Now, one thing to notice here, if you didn't catch that, is that in between going from applied to packaged, there's actually a unit change for tube burst pressure. So these GUIs can update real time depending on what you select. All you have to do is code it in. So I've chosen package, it has my start point. Now I'm just going to select my endpoint. And it allows me to change particular parameters that we chose. I'm going to go ahead and make the drawing. Asking if I want any end details. As you see, they're both unfinished, so I'm going to say no. And it says all of my drawings have been created successfully. Now, like I said, this is saving to my working directory, so all of these are still in session. If I choose to add them to Windchill later, I can. And again, this took, maybe 5 minutes, and this is a process that would have taken more than 30 minutes for our designers to do manually. This was also only 2 part numbers, whereas we can make this column as long of a list as we want and just power through this. So you can see how robust and powerful this tool could really be. All right, now since we're saving our questions to the end, I'm just going to go ahead and go on to our next program. For this program, it is a tube sheet transfer tool. Now, tube sheets are these parts that you see on the end here. They go on the end of our pressure vessels in order to hold our tube heat exchangers. So, and then on the end of these also go a water box, which Michael will show later. So they have to withstand certain pressures. And because of these certain pressures, they'd have to adhere to SME code. Now, we are a global company, which means we have design centers in the U.S., France, as well as China. Now, China has different codes than we do, so they don't use ASME. So if they start designing a product before we do, they'll design these tube sheets to their standards, and we basically have to redesign the whole thing, our codes and our standards, even though the tube pattern might be identical and there's only slight variations in the tube. But we wanted to automate this process so we weren't having doubling our efforts. So what this tool does is it actually takes a part from China, it maps the drill patterns, maps the tube sheet patterns, and then it makes a new part adhering to our codes, makes a drawing. I'll go ahead and show this. All right, I'm going to go ahead and run this. Again, it's going to bring us to a GUI in which I'm going to input a part number from our Chinese System Design Center. I'm going to pull in that part, and then brings us to another GUI where I can select certain inputs. So in here you can see you can actually change dimension. So it's asking for a refrigerant shell outer diameter. I can select the product family. I can select what PSI it has to be rated to, how many passes, and other things that can affect the design. Also, if you notice over here, it's asking to pick a surface for datum A. Since they are black, it has actually already searched for these datums. It's found them. If I wanted to change the datums, I could do so, but I'm not. I'm going to make a couple of selections here, and then we will continue on. All right, so now what it's doing is it is actually mapping all of these holes, all the patterns, all the hole tables. And while it's mapping them, it's actually also searching for any features that don't affect the geometry. So this goes along with some of the inconsistent design work. So if somebody, for some reason, put a hole out here, it would find that, realize that it doesn't affect the geometry whatsoever, and delete it. It also looks for holes that are placed exactly on top of each other that do not affect each other. So basically redundant holes, it deletes them. If there are 2 holes stacked on top of each other and they do in fact manipulate each other's geometry, so maybe one's a little bit offset from the other one, it prints it out and says, hey, I don't want to delete this because it might do something, but this is something that you should go back, be aware of, check into it. So in a minute you will see where it actually prints out those, as you could say, trouble areas for us to check into. All right, so as you see here, printed out those things that we need to check into later. And the whole time, it is printing out certain things down here. As you see, mass properties calculation 100% complete, task complete, starting convert blank family. And again, the blank is just the, I guess, the outline of the tube sheet itself without all of the pattern. Now here it's asking if we want to adjust, edit, or delete any features, and I decided I did want to edit some. And as you can see here, we can actually show what those dimensions were and then adjust them as we choose to. I believe we're having slight technical difficulties on our end here with our video freezing up a little bit. All right, so what got skipped through there is first I decided I wanted to adjust some of the things, and then I went back and actually deleted them. I think we're having some Wi-Fi issues, and that's why our video keeps jumping around here. But again, this is one of those parameter GUIs that we said we can adjust. We'll put in an email here for some of these things that will get populated into our drawing. So I want to copy a blank drawing. Now this is, again, copying a Chinese drawing that has already been made. It maps where these dimensions are placed and places them in the same spot. It also can convert Chinese to English, which is very convenient for us having a Chinese sister design unit. All right, so my blank drawing is complete. I'm going to move on. Now again, it's asking me if I want to edit any features. Again, just to show the functionality, I'm going to say edit a feature. I'm going to click on one of these holes here. All right, and it shows the dimensions, allows me to change any of those dimensions that I want to. I choose not to do so, and we will continue on. All right, again, populating certain parameters that will go into our drawing. I apologize for our video being a little bit skippy. We've been having Wi-Fi and network issues for the last 2 days. All right, so now it's going to begin my drawings. Now what this actually does is it counts the amount of instances, and depending on how many instances are in the family table, that's how many pages, how many sheets will be made in this drawing. And you can see here it's bringing in dimensions, it's bringing in detail views, it's bringing in GD&T, it's bringing in notes. So you can just see how powerful of a tool this can really be and how much time this can really save us. This is a process that would typically take a designer at least a day, if not more. And now we're about to do it in maybe 10 minutes, let's say 30 minutes to an hour with a little bit of cleanup at most. That's basically the end of this program. So I just want to reiterate what sort of functionality in SmartAssembly we've shown here. We have shown making drawings that bring in dimensions, GD&T, engineering notes, title blocks, revision blocks. We show communication with data management software. We show communication with Excel. Now, so graphical user interfaces, there's so much functionality with SmartAssembly. It's really convenient, especially the time savings and the standardization and the reduction of errors that it can offer. So I'm going to hand this back over to Michael, who's going to go over our final program. Michael?
Before I get started on the Waterbox automation tool, in anticipation of a question that I just thought of, one other program that you're not seeing here today that's related to those tube sheets is a DXF Creator. So from those tube sheets, we create DXFs for our vendors so that they can program in the hole pattern and cut the tube sheet. So we have a program covering that portion of our process too. As far as Waterbox automation is concerned, the big functionality that we have not seen yet is assembly work and just a large-scale drawing automation. This program that we're about to see creates parts and drawings for almost everything that makes up the assembly that you're seeing there, as well as one level up. The challenges here are that for a given product line, we make somewhere on the order of 1,000 to 1,500 different styles of Waterbox, and covering all of those styles with a program is an immense workflow problem. We're almost done with that. Its tool is still at the end stage of its development, as well as creating all of the drawings and placing all of the GD&T and hammering out the design standards to a level where we're happy with the output of such a tool. So we're going to go ahead and get started with video number 3. So the first thing I'd like to speak to is in a moment I will open up an Excel input file to show an example of how we communicate the plethora of information that is needed to create a singular set of water boxes. Each run of the tool creates somewhere between 48 and 120 water boxes because it creates several drawings, and each drawing has between 12 and 20 configurations on it. So let's skip forward until we open up the Excel file. You're seeing part numbers here. These part numbers actually end up in Windchill as part of the workflow of the tool. So we're going to run what's seen in the 3-pass configuration. So those numbers are actually being checked in as drawings are being created when the tool processes. So I'm going to go ahead and launch the tool. We're seeing my workspace here. I am going to use some PDM functionality throughout the run of this tool. Note that standardized icons can be made in your program interface so that the pictures mean something and make your user's life easier. We get a couple warning messages up front, just warning the user that we will be seeing some erase not displayed and workspace clearing functionality as the tool runs. This is the first customized GUI we see for this tool. This is just the user selecting options based on what the engineer has specified in the inputs file. Note that there are 3 question marks here. This is specific to this GUI because we have not selected the inputs file we want to use yet, so that it doesn't know what to put in those cells. But after this, the first thing that will happen is we'll select that inputs file, and the following GUIs will be filled out fully per our configuration. So I will take a few seconds to enter the necessary inputs, also found in the inputs file, and click the radio button specific to the configuration we will be running in this demonstration. We will be running a flat cover water box that is that conforms to 300-pound design, ASME, and is a condenser water box. Note that as I clicked through the different options, the picture changed because it gives the user an idea of what will be created and what he'll see when the tool is done processing as far as the assembly level is concerned. So now that we've selected our options, we're going to hit check. It will bring us the file dialog so that we can go find our Excel file. we just made our group just made a common location that everybody could get at the file dialog. Now note that we have a new customized GUI that tells you what all the dimensions are put in, and it has some notes in there so that you can know what works and what doesn't work, but we're going to move through these quickly as all the numbers are already populating. So as we get here, one thing that the reason these are blank is I did not fill them out in the engineering inputs file. So the parameters that we're seeing here are common revision and title block parameters that are shared across all the drawings that will get created in a moment. I'm going to take a few seconds and fill those parameters out. The next GUIs we will see are the part number GUIs. So please take note as we see them that some of the fields are not filled out, but the fields that are not filled out are also grayed out, and that's because they are not needed for the configuration running today. Okay, so we're going to click our way through. These 4 part numbers are the 4 tube sheets that are needed to create the water box and tube sheet assembly, something that would have come out of a tool such as Tanner just showed. What it's going to do when we hit the green check box is it's going to show us, or it's going to go into Windchill. We'll see the PTC clock in a minute as it goes and finds the data from Windchill. And once the data is retrieved, we will select the assembly references needed to assemble these components in the assembly so that when it gets to that program, it's got all of the information it needs to complete the program. So we're just going to wait a second or two as I make my way through selecting all 4 sets of assembly references. It is worth noting that I have not yet programmed in functionality to automatically set the display settings as you do this, and I certainly could do so. SmartAssembly gives you that functionality. It was just lower hanging fruit than is on my plate at the moment, so it will be probably something I handle in the next week or so as part of this tool's development. All right, I believe we're on our 4th tube sheet now, so that once I hit check, you can watch the message window down here in the corner. It's going to go grab some information from Excel. What it's doing is it's getting standard pipe thicknesses, existing library part information that it needs to complete calculations and size different holes and assembly offsets at the assembly level. So now we get to see our first part get created. It's creating the shell for the assembly. This is a low nozzle exit. If you were paying attention, you would have seen that it found 1 shell, so the high nozzle shell was already out there when we created. Immediately moves into the drawing phase, and as I said before, it's going to check in the drawing as it moves along. It found some other parts that already existed in Windchill. They must have been shared between different past configurations. And as a result, they didn't get created because it said, hey, this is already in Windchill. I don't need to create this. So part of the reason it's finding parts up front and not creating everything is because we had already run the 2-pass configuration before we ran the 3-pass configuration through this tool, and some of the parts are indeed shared. And we'll see this in a moment as it starts to look for nozzle parts, because absolutely all of the nozzle parts are shared between both 2- and 3-pass configuration. We're about to see the first assembly get created. That doesn't get assembled until the very end, but we'll get there, I promise. One thing of note here is there are loops happening in the background. One of the inputs is the number of bolts. It both drives the number of reinforcement ribs and hanging angle irons that we just saw, so that you can change that, and the code handles all of the math to place them correctly as you go. As you're watching the drawings get created, just as we saw in both the copper tube and the tube sheet tool, it's placing all of the dimensions, the engineering notes come in, you get a fully filled out rev block and title block. The only thing that you're doing is cleaning up a few things here and there for legibility, and modifying layer status as you go if need be. So as I said, if you notice now, if we pause the video for a second, you can see that down here in the bottom left corner, it's telling you that it found a bunch of nozzle parts in Windchill, and that's why we didn't see anything get created, is because it said, hey, I found it. I'm going to go pull it into my workspace, and then I'll use it in a moment to assemble. So that brings us to the assembly level. You can see that if it's moving fast enough, I don't know if we're having some WebEx lag, but it assembled 2 tube sheets. We have 2 nozzles, which is never the case. So basically what's happening now is building the generic for my family table where everything exists, and then it will change part numbers and suppress things as needed. And that's what's processing now. That regeneration is it creating a new instance as it moves. So it's going to go and it's going to work through creating the family table. This is a bulk of the processing time because the tube sheet models have, as you saw, quite a few holes in them. So regenerating all of those patterns is not a insignificant task. One thing that we'll see in a moment is it is going to create some assembly features. So SmartAssembly does have the ability to create assembly level features. And one of the other bits of functionality that I show here is that I actually roll back the model as I'm creating that assembly level feature so that I can put it in the right place in the model tree. The reason I did that was because I was seeing a little bit of issue with my code as the if the assembly level features that are now being created were created before the family table, it would error. So I chose to create the full family table and then roll the model back. As you see, many of the items in my assembly are now suppressed because it's been rolled back, and create the feature prior or after rather than the family table. So there are 4 assembly features, and every time you see that box, that's a feature that we create in our design standards as part of a marine water box, which is what we're seeing here. So in a moment, we will be done because that is the last step of the water box and tube sheet assembly creation process. So for brevity's sake, we're only going to watch enough of the drawing to see the family table and illustrate how many instances were created. And we're going to skip a lot of the drawing creation here because we've seen drawing creation in several other places and already demonstrated that functionality. Then we'll jump to the high-level assembly just so that we can see one more time that it's very powerful from an assembly level standpoint. Then we will open the floor for questions and discussion. So I would like to take a moment to thank Ron and Jennifer for giving Tanner and I the opportunity to present today. Now we're seeing our SmartAssembly table. So this one has 12 instances in it, and during the run of this tool, 4 different water box and tube sheet assemblies are created. So this one run would result in 48 different configurations of water box at the end of the day, and 8 configurations of nozzle arrangement assembly that we will jump to now. So I skipped the video forward to the end of the water box and tube sheet. One thing of note here is that you can see that now we have a low nozzle exit. Oops, I let it move forward too much. We have low nozzle exits here as opposed to the high nozzle. That's one of the differences in configuration of water box that drives us up to a number 48. And now we're going to skip forward until we see our nozzle arrangement being put together. So here it's regenerating all of the different water box and tube sheets. You can see it puts a bunch of different instances down. After it finishes putting down instances, it will put in the necessary blank offs and different shipping parts that are needed at this level so that our units can actually go out the door. We're going to skip to the end of that just so that we can see a cover. I take a moment here just to show you my email address if the video wants to open Outlook for me. I thought that's what I was about to do. You can see the blank offs now, the black pieces on the flange. It puts in the gasket on the front, and we'll finish the day with cover assembly. That's where I wrap up the functionality of the tool, and then I go into Outlook as stated and just gather my email address. If you want Tanner's email address to ask something about something that Tanner did, you can ask me, and if he wants to shoot me down, he can shoot me down and not you down. But that covers pretty much everything functionality-wise we wanted to talk about today. So now I am going to go back to our presentation and close out of my video and open the floor to questions. And one more time, I'd like to thank Ron and Jennifer for allowing us to give this presentation today.
Yeah, great, Michael. So, oh, sorry, there's a little feedback here. So I've tried to mute all of you. If you have any questions, please just go to the panel, the participants panel, and click the little microphone to unmute yourself and ask the question. And we'll have about 10 minutes of questions before we wrap up. You're also free to chat if you want to write the question in the chat. You know, I'll be glad to read it if you're more comfortable in doing that.
I think someone just did that, Ron, because I saw. The first question we have is, can we receive the video, please? I think that's aimed at you, Mr. Ron.
It is. So what's going to happen as far as the this recording is it'll take a little bit to generate it, and then we post it to our YouTube channel, and then we link it to the PTC User portal where the webinars are, and we'll attach this presentation, Michael's presentation, in PDF format, so you have that as reference. So Mike, I suggest if you haven't, put your email addresses in that, and this way when they get that, they can reach out to you reviewing the presentation.
Okay.
I have a question.
All right,
Michael. How large are these overall assemblies of these units once they're done, part-wise and meg or gig-wise?
I'm sorry, I didn't catch that. Can you repeat the question?
How big are they? The file types?
Sure.
How big are the files?
Yeah, how big are like that go into Windchill?
Oh, okay. So the coding files don't actually go into Windchill, and the files that contain the code are rather small because they're just text files. The actual CAD parts are about.
Go ahead.
They're about what you'd normally see for a CAD file. For some of the family tabled stuff, they get pretty big just because of the different features, the different table patterns that go in. There's some pretty complex features in there. But offhand, I don't have an actual number for you. I'll have to please get my email address, and because we use Windchill, we don't worry so much about file size. You would have to I'd have to pull one down and put it on a Windows server, and you look at the properties to give you an actual number. And I could do that. Just please follow up with an email, and I will do so.
Okay. So you've always used SmartAssembly in conjunction with Windchill?
Oh, yes. Part of that program you saw, the Waterbox tool, we were actually connected to our product data management software. It was both checking in the files that were being created, and it was pulling some standard parts from our already existent library. I'm seeing a lot of questions come through chat, Ron, and I'm not able to keep up with all the chat people, so I don't know if you're going to be able to pull those down.
Oh, yeah, I will certainly. Yeah, I'm not sure we'll get to them either, but we'll definitely save out the chat and make sure that we have it. So let's just go. So I'm just going to grab some of these. One from, I think, Eric. How much background time, effort, people is involved in setting up the GUIs?
So the GUIs were set up entirely by a programmer. So for example, on the tube sheet tool, Tanner didn't actually make that one. It was made by one of our designers named Brian Foster. He did all of the GUI work for that. It was done by him and himself. All of the GUIs that you saw in my program were created by me. So the only thing that makes those take a significant amount of time is, one, understanding your customer needs so that you get the right numbers in the GUI, and also making the pictures if you're going to make pictures. So, and the way that I did that was just pull a Creo model, print a PDF, and screenshot it.
I would go as far as to say creating the GUIs and coding the GUIs is an insignificant amount of time compared to creating the rest of the program.
Yeah.
And of course, that depends on program complexity too.
Yeah. Good. Excellent question. So next question here, which version and build of SmartAssembly are you using?
I'm sorry, ask that again?
Which version of SmartAssembly and build are you using?
So the programs you saw in this video were all M70 build SmartAssembly. We have not quite utilized all of the M70 functionality yet because we only recently moved to M70, but that's what the programs were running. So SmartAssembly 6.0 M70 is the answer to that question.
Good. Excellent. How long does it take, min-max time to set up a typical SmartAssembly, program?
Okay, so wide variation on that question. For example, Ed Carrillo was the designer who created the copper tubing tool, which is a fairly simple tool, and so he developed that within. So we were trained in November of 2017, and he started developing tools in January of 2018, and by March of 2018, that program was live and out and running.
We've made programs in 2 days, and we've made programs
in a year.
2 years.
Yeah, so it all depends on program scope and how well. So part of the reason that some of the programs take a long time is SmartAssembly, while a great program, forces you to have a much more deep understanding of your products, because a lot of times in our ECN process, what happens is somebody will make a part, and then they'll see that something's wrong, and they'll ask the designer to manually fix it. But what we're trying to do is better define the rules of our product so that it gets fixed the first time by the program, and we're minimizing cleanup. So it's a trade-off between development time and cleanup time.
That's great. Yeah, I know it's a tough question, and we've seen it ourselves. So, but this is a more defined question. How much training does a typical user need to be able to use SmartAssembly?
So if I were to average it, if I were to average it out as far as designers on site, we had 2 designers get 5 days of training, and 4 designers get 0 days of training. So basically, what we've done is we took the training from SmartAssembly, which, to speak to it, was a fantastic training. But another thing that SmartAssembly has done very well is wording their coding in such a way that it's intuitive. So, for example, there is a command called assemble inside of SmartAssembly. It assembles stuff. There's an erase not displayed. It does exactly what it does in Creo. So if you are a native Creo user, it's very intuitive to find what a lot of the commands do, and with a little bit of a coding background, the training needed is minimal to get started.
Especially with the administration guide that they have, it's very easy to, since the names of the functions are so closely related to what it actually does in Creo, it's really easy to search for what you want to do, be able to find that function, and then in the administration guide, it actually sets up, it gives you an example of how to use the function, as well as certain options for inputs for that function. So, I mean, I myself started using this in January. I had no formal training, and I've already released a couple programs. So, mind you, they're short programs, but I'm still working on the larger programs like the water box tool you've seen. So, I wouldn't say it's necessary to get the official training. Now, if I had the official training, would it have been a lot better? Probably, definitely. But it doesn't take long to pick up and get moving. It takes longer to be an expert and to be, the best of the best. But to start making programs, it's not that long.
Okay, good. If I would add, and I don't know if you both agree with me, you can have a good programmer, but if they don't know Creo, that's a problem. We feel you need to know Creo, and then you could kind of learn programming if you need. Is that a fair statement?
Yeah. The coding structures within SmartAssembly, as long as you understand basic loops and if-then logic, I would say that it's more knowing the Creo side of things than the coding. Yes, completely agree.
Yeah, all of our coders are Creo users and start as Creo users.
Okay, That's good. That's excellent. So let's see. Let's ask one. We still have more questions, and this is great. What we may do, depending on when I get these questions to Michael and the team, is if they, if they want to respond textually, or we want to set up another one where we just have a Q&A. We've done that. We'll do that. But let's just have one more question before we wrap up here. So how much effort did it take to have the Chinese to English conversion? They'd be interested in English to Japanese, another, same lettering, but different language, right?
Right. So the way we're handling different language notes on drawings is not actually physically doing the conversion step. What's happening is we have a designer in our China facility that writes the notes for China. We have a designer in America that writes the North American version of those notes, and they go into a sub-program that's GUI driven to pick what set of notes or both notes if you need both sets of notes. So they would actually, SmartAssembly is not a translation software, so you need somebody that knows each language to write that language of notes, and then the program can just pick what notes it wants to use.
And you don't even have to manually pick it, as long as, because it works with Excel, you can write a VLOOKUP program, and as long as you have your keywords correctly, you can more or less make it into a translation software. You just have to translate everything beforehand, and then
it could go stitch together languages for you. Yeah.
Correct. Yeah.
That is we have not gone that far, but he's right. You could have an English to Spanish to French to Japanese to German dictionary, and it could just say, I need this language of this word, and go find it.
Good. Excellent. I'm going to ask, because we got 3 more minutes, but I do want to do the wrap up. Just one more question, because this is a really good one, because it talks about beyond like what you normally see in Creo. So one of your demonstrations showed GT populating automatically in the drawing. Do you provide that detail in the part in advance or part of the program? I think that's more or less the question. So how did you approach the global dimensioning?
So one of the more intricate operations inside of Creo itself, outside of SmartAssembly, is to write a user-defined feature. And that's what SmartAssembly relies on. It does not actually create any of the geometry on its own, with a few exceptions. It can create holes on its own and stuff like that. But what we do is we create UDFs up front that populate annotation features in the model, and then the annotation feature from the model is shown on the drawing. That's how the GD&T gets on the drawing.
I think it's a great question, because again, all SmartAssembly is doing is automating Creo functionality, right? If it's in Creo, most likely you can automate it, and so I think that really tells the tale. Also, Michael, you'd agree, you can separate if you automate something in Creo and sigmax goes away, it still works, right? Creo is Creo.
Yeah, it still works. I think I understand the question. So if sigmax were to go away, you could no longer run these automated programs, but the models are still there. Once the models are created by SmartAssembly, their Creo model is segregated from the program, which is a leg up on Pro Program, because Pro Program all lives within your models. So it can create everything, and then it's just a standalone model that no longer relies on SmartAssembly.
Yeah, perfect answer. That was the crux of the question. So I'll hold off there, because we're right at the hour. I respectful of people's time. Again, we'll have thank you. Great presentation. I was really engaged. I know. I can tell from the people and the questions on the call. All of you were as well. We'll get this video posted, and go look out for that. Say latest Monday and Tuesday. I don't want to overburden people with emails, but I'll of course do that. We'll have we have some future webinars lined up. One I could tell you, we're advanced stages is Creo Illustrate. So those of you who are interested in that space, will definitely want to attend that event, and I'll be communicating those out. So again, thank you everyone for participation, and look forward to seeing you on future webinars. Everybody have a great rest of their day, and take care.
Thank you.
Thanks so much.
Thank you.